This is the BioImpact Silicon Valley, a series of 5 interviews of key players in the biotechnology space. They shine a light on why do we actually need biotech in our world and why we should care about it. Enjoy.
Hi everyone, I have the pleasure today to have Maya Lim with me. We're going to talk about biotech and the impact it has on the world. I am Michael Mangold, host of this interview. I am chemist by training, but also passionate about science, technology, communication, and how we can make this world better. Maya Lim has a PhD in chemical engineering. She's born in Singapore, then studied in the US, worked in the Silicon Valley for almost 4 years when this semiconductor boom was going on, then moved to London to do her PhD in biotechnology, stem cells to be exact. Moved back to went to Singapore, where stayed in academia for a while, and finally moved back to Silicon Valley to continue her adventure in the startup world, and now doing a massive impact in the biotech industry. Maya, it's a pleasure to have you today.
Thank you, Mikhail. Thank you for inviting me.
Sure, and it's an immense pleasure because I like your profile of being in academia so long. I know you switched to business and marketing, and I really want to inspire the young audience to maybe find motivation for biotechnology, but also just professional senior employee that want to change and to see that biotech is cool and biotech can impact lives, and biotech is not just a scary thing that is doing bad stuff to the world. My first question is, you had an incredible career in science, but we know that science is going to be more important in the future. What was the spark that really motivated you to decide to study chemical engineering?
Right. Thank you for the question, Mikhail. I think that's a great question. When I was young, I have always liked to, I've always enjoyed science, I think, to begin with. And I've always enjoyed solving problems and troubleshooting. And I was very fortunate to have a math tutor who, put me on the right path and really trained me well to excel in mathematics. So I really enjoyed math, problem solving, and really later on decided that chemical engineering was probably the path that attracted and appealed to me the most. I think when you first get into a program, you don't really fully appreciate or understand what you're getting into until you start learning about the field. And I tremendously enjoyed every single moment of my undergraduate degree in UC Berkeley. So I think that was an amazing time, and I learned a lot, made a lot of great friends. And I realized that chemical engineering as a field really expanded all the opportunities that were presented to me as a young engineer and moving, even now, right? So I think that was the right choice, and I'm really glad that I took that path.
So can I say then that the spark was basically your math teacher, right? That really sparked your interest in numbers, data, and trying to do more of this. Awesome.
Absolutely. I think having a great mentor in my really young life was very helpful. She put me in the right path and made me realize what I enjoyed, and led me and compelled me to do more and pursue further a career in engineering.
Awesome. Good to know. And I think that's so important, actually, that the people is what make you decide things in your life. It's not, like whatever you learn is really about the people that show a passion. And I truly believe in this as well. All right, next question. I know you work for Rooster Bio, and you are a technology evangelist and trying to build a brand, marketing, and making sure that you're sharing the right message for the company. But I notice company is in the field of regenerative medicine, and I notice it's also an emerging field that is gaining a lot of momentum also right now because of COVID. Can you tell us very, I would say, easily, what is regenerative medicine, and what are you trying to do in the world with Rooster Bio? What are you trying to solve?
Right. So, so the field of regenerative medicine is quite broad. I think the concept or the fundamental idea is that we would be able to use something like stem cells to regenerate the body, right? It could be just the cells itself, or it could be sort of like a tissue engineering approach where you combine the cells with some kind of a scaffold to replace a bone or a cartilage, right? So those are just some examples of regenerative medicine. Rooster Bio, we're in the business of providing very high quality mesenchymal stem or stromal cells. And these cells are, what most people will consider them as adult stem cells. I think most people are familiar with that. They're typically derived from healthy donors, and they can be from like the bone marrow, umbilical cord, or adipose tissue. So traditionally, these high quality MSCs is a very scarce resource, right? What people would have to do is they have to source their own materials, they have to isolate these cells manually, and then they can use it for whatever application they might be using it for. And this is a very labor intensive process. It doesn't produce consistent results. And therefore, it becomes a huge bottleneck for the whole industry, because product developers have to source their own materials, they have to isolate these cells, create their own bank, et cetera, et cetera. So it's a very long process and takes up a lot of time. Now, a lot of times what we do here at Rooster Bio, we like to parallel ourselves to the semiconductor industry, right? So imagine if you're a computer device manufacturer and you have to create your own microchip before you can even start building a computer or iPhone, right? It would take you years of development time and a lot of resources to achieve that final goal. So what we are trying to do for the regenerative medicine industry is to create this stem cell microchip so that product developers can actually immediately use our products to create their own therapeutics and accelerate the commercialization of these regenerative medicine products.
Awesome, awesome. And I think it's a field that gained a lot of interest. I've learned this field for the first time when I listened to a podcast that is called Bulletproof, and it was talking about stem cells and how you can be younger. And I know it's one of the methods that the rich people are using right now to to feel better, but it's a very costly method. But very quick about the timeline of this science. When did this research started to be commercialized?
When did this? What do you mean by that?
What I mean is, when did you leave the academic labs and it started to really gain interest to be industrialized and scaled and things like that?
For myself, you're saying, not for the industry.
No. Actually, I was wondering about the industry of regenerative medicine to take stem cells and to try to. I know it's labor intensive and all that. Yeah.
Yeah, I think it really took off. Well, I mean, the first, MSC, I guess, therapy was probably in the 90s, in the mid to late 90s, right, where people started to look at how you could use MSCs in therapy. So I think the early 2000s is when you start seeing a lot of the clinical trials starting to take off. So that's where we take, I guess, basic research into the clinic. So early 2000 forward, we started seeing a lot of applications of using MSCs in regenerative medicine.
Awesome. I'm really excited to know more about this because I've gained, tremendous interest in it. I still don't understand everything, but it looks fascinating. I don't want to talk more about this, and I would like to jump to the next question. The next question is, we talked about regenerative medicine, but in general, biotechnology is like these big words with so many applications behind it. What do we think is a problem in the world that will be solved by a success in biotechnology?
Well, biotech is a very broad field, right? So there's so many different tools and technologies out there that could be used to solve any problem really. I mean, if you take, for example, CRISPR, right? It's one of the most fascinating and fast growing, evolving field in biotech. You could use it to treat diseases, which people are looking into that right now as a cancer therapy. And you can also use it to for environmental sustainability or address issues in climate change and so forth, right? For example, creating better crops, right, that could be resistant to pests or insects, or more resistant crop that is that rely maybe less on carbon-based fertilizers and so forth. So overall, reducing our environmental burden. So there's a really broad scope when you say biotech. There are just so many things you could talk about and you could really get into. I think it really depends on what your interest might be. And for somebody who is new to biotech, I would definitely encourage them to explore the different possibilities and identify a specific area that they're interested in, and really pursue and hone in to be an expert in that field.
Yeah, thank you so much for explaining, giving examples such as CRISPR and crop science. But according to you, what is the biggest problem that we have in the world right now that needs more scientists to solve it? Do you think the biggest problem that you believe biotechnology can solve, do you think it's more agriculture? Do you think it's healthcare? I know they are different, but do you have like one thing in mind that is really a big problem that we need more people on it to work on it, to solve?
Well, I'm always passionate about healthcare, and I think that's really why I stay in this stem cell regenerative medicine field. I think there's a lot of possibilities. So I'm personally excited about the cell therapy, gene therapy, and regenerative medicine fields, because I think there's a lot of opportunities there where we could really cure numerous diseases, right? Such as cancer being one of them. And even recently, take COVID, for example, right? We know that MSCs have potential for treating very severe COVID patients who suffer from acute respiratory distress syndrome, ARDS, right? So traditionally, this condition, ARDS, it doesn't have any therapeutic options, right? The only thing you can do to help these patients is to use ventilators and fluid management, right? And even with that, the survival rate or the mortality rate is fairly high. It's around 20-25%. And in some cases, it could be as high as 40%. So, this is where something like MSCs can really play a significant role in managing immune overreaction, cytokine storm, clearing the edema fluid in the lungs, or potentially even clearing the pathogen in the lungs, right? So I think that something like stem cells and MSCs can provide better alternative for certain patients as a treatment option. And there's just tremendous opportunities that extends to tissue engineering, gene therapy, and so forth, providing better medicines for us in the future.
Amazing. So many, we can see the passion that you have for stem cell research, and I think that's definitely a problem that people can focus on to solve diseases. Let's go to the next questions. And the next question is actually that often people, and I think there was even worse in the 80s, see biotechnology as something that is going to be negative for society, that we're going to control people, that we're going to make, we can change the kids, we can change the colors, that there will be like the rich are going to be richer because they can, be superheroes. What do you say to these people that are afraid of biotechnology and all the people that are modifying genes and whatever?
Well, for the researcher and scientist, obviously there's the ethics, right? I think that, every researcher and every scientist have the responsibility to act ethically and morally, and not, manipulate things to their own benefit. So there's definitely an ethics committee that should be overseeing some of these activities, right? So that, unforeseen or undesirable consequences will not ever happen, right? So I think there's definitely that component that needs to be reinforced, right? If not regulated at some levels, right? But for other people who are not in the field, and I would say that, to take the opportunity or take the chance to understand the technology, right? And try to really understand the kind of weigh the balance between risk and benefit, right? With every technology, there's always some risk involved, right? And I think that as human beings, we just need to kind of manage those risks and understand those risks and not fall into the wrong hands or take the wrong path, right? And if we held ourselves responsible and also, respect what we do and respect other people, then I think we will get to a better place using these tools, not abusing them to create a better world.
So basically, you're saying that let's trust each other. That we have to be responsible and we have to be ethic. That's an ethic matter, and that the probability of people doing the wrong things have to be small and should be small and will be small, right? Is it basically the
Yes,
conclusion?
absolutely. I mean, there's always bad actors, right? And you can't really control 100% of that. But I think as a society, as a community, I think we're all doing all the right things to make sure that bad things like that don't happen, right? So, I mean, a great example is the CRISPR babies, right? It's unfortunate that we had that incident 2 years ago, but, I think the community is doing things to make sure that this doesn't happen again.
All right, thank you. I think it's great to see that you mentioned this example, like that people now are aware to control this kind of incident. I'm very curious about your answer for the next question, because I know that you're also passionate about communication. How do you see scientific communication before and after the pandemic? We know that fake news is one of the biggest problems of our time because everyone has a smartphone, everyone can tweet something. What do you say about that?
Well, I think many things definitely changed since the pandemic, right? I think that it's difficult for us to control what other people have to say or want to say. I don't think that is, that is as easy as we like to control them. But I think from my perspective and from either as a researcher, academic, or an industry player in the field, I think that a lot of the interactions have changed and we have to adapt and change because of the pandemic. So a good example is live events and conferences, which traditionally have always happened on a very regular basis, which again is something that it's a platform for researchers, scientists, and industry players to kind of interact and share knowledge, right, and learn from each other, right, learn best practices and so forth. And that has become tremendously compromised because of the pandemic. So everything is now going virtual, and obviously there's components that you can't have anymore. And these are things that obviously we can't control. We have to adapt because of the changes. But I think that the pandemic has also given us new opportunities to sort of adapt and find new ways to engage with each other, right? So we're definitely seeing a lot more webinars, for example, that are hosted on a regular basis. And people are taking these conversations online, more on the virtual world or social media, let's say, for example. And what we're doing right now, these virtual interviews and podcasts are becoming more and more popular. So I think that it's a good opportunity for everyone to become more engaged in the virtual world or in social media, and just sort of listening to these conversations and making the best judgment, right? I think that not everything that you hear could be accurate, but you have to really learn to be more discerning and critical about the things that you hear on social media.
And what would you say to someone that, I think this situation is for the people that are already very interested in science. What do you say to the people that are maybe not very into science, and how should they see how do they become a critical thinker, that what you just said? Do you have any advice for these people?
I think having conversations with people that you know who are scientists, right? So obviously friends, family, an extended network, engaging with them and just asking questions, right? If you don't know whether it's true or not, right, then ask these questions, and and through these conversations, I think people will learn and be enlightened, right? So I think the key is not be afraid to ask questions.
I love this advice, not being afraid to ask questions and staying curious, right?
Yep,
That's
absolutely.
I love it. Now that's the last and final question that I believe for me is the most interesting one. We want that people have ideas, innovate, impact the world. But what I realize is sometimes it looks so far away, it's so big that it's almost impossible to know how to achieve this goal. What is your advice to actually have this big vision and to start with the small little step that will lead to this massive impact?
Yes, I think that first of all, I think that it does not matter where you start, right? So I think you shouldn't care too much about where you start. I think starting something is always a good thing. So, and it doesn't matter how big or how small that vision or dream that you might have. I think that each and every one of us can make an impact, no matter how small it is. And if you start that way, if you start with that kind of process, that's how you slowly build towards that bigger goal, right? I think to me, what is really important is the journey that you take, the path that you walk along with other people, right? This is going to be a marathon. This is not going to be a sprint. And, you just have to take things step at a time and putting your best foot forward every single step of the way and just never giving up. And if you take that kind of approach and mentality, then eventually you will get to a bigger goal that you've never maybe even imagined or dreamed of. I think just keeping to the path that you're taking and having some faith and trust in yourself. It's what it takes, right, to get you to the final goal.
Thank you, Maya, for this great advice. To sum up, I will say that what you just said is if you want to have a massive impact, you have to be happy and fulfilled to have a small and little impact at the beginning, because this small and little impact is the fuel to have a massive impact, right?
Absolutely. I think you summed it up really nicely. So yes, I think that every one of us can make, some contribution, and over time it's going to be a huge contribution, right?
Yes, I love this. Maya, I think we are finished for today, but I would like to ask you, where can people find you, connect, learn what you do?
Absolutely. Thanks, Mikhail. I'm definitely, everyone can connect with me on LinkedIn. I'm definitely pretty active on social media, whether it's on LinkedIn or Twitter. So feel free to reach out to me on LinkedIn, and I'd be happy to, make a connection with anyone out there who's interested to learn more about biotech, or stem cells and regenerative medicine.
Love it. Thank you for being so open to connect with the world. People have to connect with you to learn more, because I think this is a fascinating field. And we have to have people like you that are experts and that are sharing and are trying to take the time to inspire others. Thank you, Maya. It's been a pleasure.
Thank you as well, Mikhail. It's been a pleasure speaking with you today.